Nathan. Yeah, but this is kind of weird. So, good question. We normally will be switching groups/seats like every couple weeks. We have 2 days left in this chapter. Really kind of like 3. So I'm going to try something real dangerous here. Everybody stand up. You straight where you are.
Everybody.
If you want to move where you're sitting, pick up your stuff and move. If you like where you're sitting, and you'll find, like, just sit your butt back down. We only have 3 more lessons in this chapter. So if you want to, now, so really, groups should be at least 3 for good conversation. Pairs is kind of hard. So try to have at least 3 people in a group, but if you want to sit somewhere else, and like next chapter, we'll try to make available the back counter for some other people, because I know the same groups kind of stand out. Then, yo, people, I liked giving you time for homework last week. I would love to do it again. Then, everybody should have done what already? Written your homework in your plan book, and then what do? Exactly like what Greta's got going on. Graph paper, pencil, and header. I think right now Greta would win the award for the most ready person in the class. Kevin's almost there, he needs a header. Kevin's almost there. Ivan.
I have the worst cough I've ever had.
Did you guys have a good weekend?
No.
For those of you saying no, you just need to adjust your attitude. I can't hear a lot of crazy sounds. Because I was alone. No one else was camping. No, we were camping was a stretch of the word. We were watching Ohio State games. Yeah, that makes sense.
I didn't take over on the
No, they only went through once. So I made a front back for this one. I had, so this is what I need for these guys, but I had sent it through to make a front back for these. And it doesn't have to be front back, and it's pretty in case they screw up. Alright, peeps. Minor. Yo! I should not have to keep competing so hard. So, here's my deal. The further we get into the year, the less loud I'm going to be. Well, intentionally. So, like, we're 3 minutes into class and we haven't gotten anything done because I had to pass out a few papers and I had an issue with the copier and Mr. Smith's trying to figure that out. But I shouldn't have to, like, say the same thing 3 times to get people to, like, be quiet enough so you can hear that the teacher's talking. If something else is going on and you guys have time to chat, that's okay. But you need to be on task. So my issue is that some people aren't anywhere close to ready for class. Quit using my materials to be like Justin Bieber on your binder or whatever you're doing. Hey, I don't care. When would be an appropriate time to do that? Potentially, AO or extensions or break for sure, or if a teacher hasn't been like starting class yet. So is your homework in your plan book? What? Is your homework written in your plan book? Layla, you need to sing me after class. This is unacceptable. I'm not joking. I like you very much, but your student behaviors right now are not where they need to be. So I heard Mr. Cabilo asking this morning to a student, what are you attending to? Right? What are you putting your effort into? What do you care about? And he went on to tell the student, because right now I can tell it's not school. Right? Every Monday is kind of difficult because you guys shift back in from that mode of like, hey, it was weekend, whatever, to I'm back at school. But we're over a month in. You know what's expected of you. It will make your life easier if you just check the boxes that you know to easily check. Like, I know that if I want to, like, make my wife happy, I can put away the dishes. Right? That's an easy thing. When you walk into this class, it's plan book graph paper. Right? From day one, it's been fill in your plan book, get out graph paper. Then you go the extra mile, put a header on it. So that's why I was saying Greta won the award for, like, most ready for class before I even asked what do you need out? She was ready. Everything out. Now I'm assuming she has her homework written down. I hope so. But be ready. Like, make it easy for yourself so you're not trying to play catch up once we get going. Right? The first. Today's October 1. So today we're going to start looking more at graphs, and where this is leading is some really fun stuff that we're going to do. You can really make a graph for any situation. The question is, does it make sense when we graph it? So graphs can be used, by the way, you can just say like choosing scale, graphing data, or whatever you want for your header. Really, you could just put graphing, but one of the biggest skills that we're practicing today is how to choose that skill, or choose that scale, which you've already been working on in your practice work, right? You look at how many numbers do I need to cover, like what's my lowest and what's my highest, and you kind of make that determination from there. So please make sure you have a header on your paper and that you're ready to roll. So in this lesson, we're going to work with our teams to make choices about how to set up a graph in the most useful way. There are many ways. Some are more useful than others. As we work, ask ourselves these questions. Does our data fit? If our data doesn't fit on the graph we're trying to use, it's not a very good graph. How can we make it clearer? Like, how is my scale making what I'm trying to show easy to see, or did my scale goof things up? How can we make a prediction based off what we've already seen? So if you follow temperatures, let's say we're trying to graph temperatures in Ohio, and this is January, and this is December. Right? What do you think happens as January goes into February, and February goes into March, goes into April? Probably going up, right? Then it kind of levels out in June, July, and where we're at right now, kind of starting to taper off and go back down. Right? So this would kind of be hard to use, but what if you look at how much money you have in the bank versus how many weeks you've worked? And here's 1 week, and maybe here's 10 weeks, and you got a job, like you just started it, and my money in the bank, I don't spend anything, it just keeps going up and up and up and up. That's easy to predict. That graph has behavior that we can see, we can anticipate. As long as you don't spend any money, you will keep increasing, probably in the same way. So Peyton's bats. I forget which one that's. Might as well pass these out. I'll take one back. Peyton's doing some research on bats, and bats are really interesting, actually. They're super important. They eat mosquitoes. So if you think you don't like bats, you do. Trust me, you like bats.
I love bats. Because mosquitoes can sting by their actions.
All right, so Peyton wants to know if she can predict the wingspan. Why am I still competing? I will wait. Peyton wants to know if she can predict the wingspan of a bat based off Noah's body length, which for humans, it should be the same, our quote-unquote wingspan, from fingertip to fingertip across your chest, like all the way. That should be your height. Pretty darn close. If it's not, part of that is because you're going through puberty and your body's changing at weird sizes. Other thing, I'm awkward. My arms are really long, so I have a longer wingspan than I do height. Like that, just certain bodies. But they should be very close. So Peyton's kind of wondering the same thing about bats. So she looks at these 5 different species of bats. Right? Big brown, little brown, Brazilian, evening, and Indiana. Here's the info she found. So work with your team, and you don't need this paper right now. Like we just gave it to you so you have it. Work with your team to look at what we see here. Wingspan compared to length. Try to make some predictions. If you're able to write on your paper, like I think the wingspan is blah. Like how does it compare to their body length? So you could look the comparison this way. You could look the comparison this way. There's a lot of different things you can do, but talk with your team for a couple minutes. You don't have to necessarily write anything down, but if you have a good idea, get it on your paper. Just talk for a couple minutes. Oh, they stole your slides. No, you should look at this. I'm compiling things. No, it has nothing to do with math. How does that right column compare to this? But how? How could we formalize it? Length means right from the top of his head to the bottom of his feet. Wingspan is because obviously bats have a much bigger wingspan than their body size. We humans are about the same, which is also why we don't fly very well. So you're probably moving that, getting this back. All right, anybody have a prediction? Brandon, you think you have a prediction? I was about to write seems like. Everyone on your paper, please put a 106 if you haven't yet. This is problem 106. So, Riley, what do you got?
Okay, so we said, well, yeah, but we said the opposite of that, which is the wingspan is about 3 times larger.
I mean, that's essentially what Brendan said. So, approximately what we're noticing is a wingspan, please write this down, is, I'm going to use a squiggly 3 times the length. So if we wanted to formalize this, do you know how?
No, I just had a question. Why did you put this squiggle?
Because it's not exact, right? This is not exactly 3 times. So it means close to equal. Guys, I keep losing you today. I don't know what I can do to keep you here. This is a real math symbol. Now be careful, that's different than this. This actually means congruent, which means exactly the same thing. It means equal in every single way that there is. If I don't have the equal sign, that means similar, which we'll talk about that this year. But if I do like a squiggly equals, it means approximately, it means close. So that's how we use that. Please don't mistake it with the other ones. And don't just put 1 because that has its own thing. So if we were to formally try to write this, we could say W, the wingspan, is 3 times the length. Good, jot that down. We've now created an equation, a formula. W equals 3L. Yeah.
Can I say what me and Layla thought?
Yeah, what'd you guys think?
Okay, we got all scientific. Yeah. Okay, so we said, I think that the wingspan is longer, so it is easier for the bat to like fly.
Oh yeah,
But
that is why.
But the length is like shorter, so it's the less amount to carry.
Yeah, so like what we were talking about over there, because humans are about 1 to 1, we're about the same. This is why we don't fly very well. And our wings don't really have much air resistance, as opposed to bats have everything working for them. So you're right, but if we try to formalize it in like a mathematical relationship, we need some sort of like numerical how it works. Now, another way that we could look at this that I've seen in the past before, people try to tell me, what about like plus 7? Right, if I take their length and I add around 7, well, this would be like about 12. This works pretty close. That's, okay. This is actually perfect. That one's actually perfect. So another way that you could have said it is their wingspan is their length plus 7. And that might work, but we would need some more data to figure that out. Now here's the dangerous thing about doing that. What if I have a bat that is twice as long? If I have a bat that is 10, like a big brown bat that is 10 inches long, do you think his wingspan would only go up by 3 from what it had been with it? Yeah, that's where this gets dangerous. So this is the difference between a proportional and a non-proportional graph. If we say W is 3 times L, that's an easy relationship to talk about. If this became a 10, what do you think the wingspan would become? 30, approximately, right? Approximately 30. And that makes more sense to us. So we can check these sort of things. Any questions? Did anyone think about the plus 7 or plus 8, something like that? Did you kind of recognize that? Did you talk yourself out of it, or did you take it? kind of like either would work with what we're given, right? That's the hard thing. We're only given 5 things. Either of those would actually work with the data that we have. All right, so check out the graph on your paper now, on your handout that you have. Because I wanted to make your life easy. I actually made it into a handout. So when you look at the labels here, one thing she's missing is actually her labels. What she has is numbers on there, right? She's got a scale, 5, 10, 15, 20. But we stop at 20. She doesn't have labels. So I need you guys as a team to investigate what label should be on the x-axis down here. By the way, go ahead and put an x over here and a y up here. We want to make sure that we're really comfortable knowing x is the horizontal, y is the vertical. You guys decide what labels. Now, there is a right answer and there's a wrong answer. So we have 2 things, right? Length of bat and wingspan of bat. Where does length go? Where does wingspan go? And then C is the harder part. I'm going to give you a few minutes. Peyton realizes her graph isn't great. Right? All of my points are very, very close together. She wants to spread her graph out. So what she notices is she only really uses this region of the graph. She could actually spread out the data and make it easier to see. So once you guys label what should match the graph, use the, yeah, they don't actually give you space for this. Talk with each other, I guess. I thought we had space for this, and actually that might be 108. It is 108, yeah, sorry, I'm getting crazy here. So in 108, it asks us to redo her graph using a different scale, so it shows it easier. So once you get your labels on there, as a team, decide, how do we want to change the numbers on the axes to graph this more easily, and then re-graph the points? Okay? Any questions on what we're doing? Label axes, then make a new graph in the 2-108 on your resource paper that I gave you, and put the points on there. Or does 108 still have labels? I need to scroll. I need to check what 108 is asking. But this is the problem with planning 3 different lessons for 3 different classes. I get my brain all mixed up. 108 still has it. I think in 109 we make the axes ourselves. Yeah. So actually, I'm going to give you a good amount of time. You guys are going to finish 107, do 108, and do 109. So in 108, she's been told by a friend, hey, what you need to do is change your x-axis scaling. And she takes it from 5, 10, 15, 20 to 10, 20, 30, 40. Does that make her graph better or not? If it doesn't make things better, your job in 109 is make it better. Make the graph easier to see. We will come back together in just a couple minutes, but I'm going to give you at least until 9:30 to work on this. So label 107, try 108, and if you decide it's a bad idea, you don't even have to do the whole thing. But in 109, you want to make your own version of this graph. Yeah.
We need the numbers to back.
Yeah, I'll put the table back up.
Oh, I didn't know.
So this table,
Okay.
and actually I'll zoom in on this and put that on the TV.
And I wrote it down.
Goal is to make the graph easier to see, make the points take up more of the graph. Yeah, spread it out. Yeah, sorry, Brendan is saying it better than I am. Spread your points out is what we're trying to do. So should I change the y-axis, the x-axis? Should I change both? So, baseline. And that part's like all so you would take out what's called like, so the anchor stays around the collar and the ground angle to the ground. Actually, I flew this back this morning. Yeah, that's only something so, I mean, I'm going to pursue it. So, if you want to be part of this, otherwise I can just keep rolling. But yeah, write the stuff for the people and then formalize everything else we need. So I was looking at keypads this morning, like how big they would need to be, what we could make them out of. So if you play on flats, the thing I don't like about theirs is it is a box. It's not like it's not all and what I was reading from if you're not going to pour concrete pads, then you want to like either put a back on the front or on and not a back. So if you want a longer run up with what your box is, they can start like behind the pad or like end up going around the pad. Boxing and obviously, you know what I mean? So like I was thinking almost add maybe like trapezoidal, but like no back on it. So like you have to throw by this point, but if you need a longer run up there, you can just do like small gravel and stuff like compacts. So I gotta price that stuff and decide how much longer we need. I don't think it would be a lot though.
We need to find 5. Why are you laughing? Oh, stop laughing. Okay, so we need to find 5. And then
I am not going to do 109 right now, so don't freak out on me. But if we look at 108, when she changes her X scaling, actually, before we move on to 108, we need to double check. What were the labels that should have gone here? Okay. Wingspan is up here. And you can turn your paper, which is a benefit that you have that I don't. What goes here then? Length, right? Their body length. Please make sure you have that written in for 107. Now, hear me right now when I say this. A graph without labels tells you nothing. Hear me when now, even a graph without numbers tells you nothing. Even if you say, well, I meant for one box to be 1, and that's why I didn't put any labels on. I don't care what you meant. It's what you show. Okay, if you want every box to be worth 1, you either need the label of 1 at your first box or like a 5 at your 5th box. Like you gotta have numbers somewhere, and you gotta have verbal labels. So as we get into graphing this year, I really want you guys to hear me now. You have to have a scale, and you have to have labels. Cool? Any questions about that?
Nope.
Yes. So in 108, same labels. Right, wingspan and like the same labels stay. The same Y scaling of one box is 1, but now the X scaling has changed. The X scaling is now 2. So what that actually does to our points, crams them all in an even smaller space. If you graph your points, and I don't know exactly where they are, but they end up like on top of each other. It shouldn't look right.
Like this?
No, like the point of what they had us do is it shouldn't look right. I think your one off to the right is too far. You might check. I think you didn't count by 2s on the X to get that one. Is probably what happened.
Wait, on the 2s it's oh my God.
Yeah, because the X-axis goes by 2s here. Now that was a bad idea, right? This was not good. If I look back at my data, guys. We make this X, and we make this Y, right? And they already did that on the first graph. How high does my X need to go?
To 5.
Only up to 5. And my Y needs to go up to at least 12, at least 14. So when I go down to 109, guys, you only have to make it to 5. You only have to make it to 5. Out here on the X-axis, it only goes to 5. So does that mean I can just put 5 like wherever I want? No, what should I do? Who can talk me through how I should do this? Jalen, we haven't talked today. Now, that might work, but that's not as strategic as I think we should be. There's a way to make our life easier. No? Ava?
Okay, so you have to find a way to split 5 up into, I think it's 19. I just counted.
So let's count. First thing we do, count how many boxes we're dealing with, or if you're making the graph, decide how many boxes you want to deal with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. At the arrow is 20 boxes. So everyone on your paper, please write 20 boxes. For just 5, what was it, centimeters? Or were we measuring in inches? How many boxes could 1 inch have?
A half.
4. How do I go from 5 inches to 1 inch? So check this out. Here's the work that I would almost write. Well, not almost, like I probably would. 20 boxes, and I need 5 inches. How do I determine how many boxes for 1 inch? Divide by 5, and when I divide by 5, I get 4 boxes here. So 1, 2, 3, that's 1. Another 1, 2, 3, that's 2. Another 1, 2, 3, that's 3. 1, 2, 3 on the 4th is 4. 1, 2, 3, and I should make it all the way. Now, we got a label, right? Because that should not have been written there. What label goes on the x-axis? Length. And I wasn't particular about this last time. Please put inches in parentheses. You always want to put the units so that people know what you're talking about. 1 of what? 2 of what? And then over here is wingspan, which I'm going to abbreviate WP. Should I change the scaling of my wingspan? Or was it okay how it was originally?
No.
You think it's okay? Yeah. I mean, I gotta go to 14. So, like, really in my head, I kind of think 15. Right? Things are divisible by 5. If I only have 20 boxes, like, if I do every 2 is just 1, I'll run out of space. So here, don't do this, but watch. If I make this 1, 2, 3, 4, 5, 6, 7, 8, like I'm gonna run out of space, and I don't have enough graph. So I gotta keep it at a scale of 1. So 1, 2, 3, 4, I'll just put a 5 there. 6, 7, 8, 9, I'll put a 10 here. 11, 12, 13, 14, 15 is pretty much as far as I need to go. Now please put your points. So for the big brown bat, 5 and 14, we go out, we go up, follow your lines across. And guys, we're going to label this point is 514 to get you comfortable writing the XY coordinates. Now, some of you had struggles on the homework last week. You had a question with coordinate axes saying label these points for A, B, and C. Who remembers that problem? We should all remember that problem because it was already on our homework. Now, the problem with that one that I had issues with, it wasn't on a grid, right? It just gave you the y-axis and the x-axis, and then you had some like random points. Use a ruler. If you don't have a grid, use something straight to kind of visualize across. If you have issues with that, my eyes have a hard time like drawing straight lines. Use a ruler, use something else to help you. But if I had grid lines, life should be easy. So place the other 4 points on there. If you need help, you can watch up here. I'm going to change color to make them kind of unique. So 3.5 and 10, 3.5 up to 10. 4.25 and 12. Guys, I haven't done this yet because I haven't felt like I needed to. But remember, I reserve the right to check your class notes. So if ever like I feel like people really weren't participating, weren't with me, I will collect your notes from today as a practice grade, like as an intro grade. So you guys know we split our grades into three things: intro, practice, and mastery. So sorry, I said practice, but I really meant intro. What we do in class is your intro assignments. Us do like you engaging in class and taking notes, that's your intro work. I don't normally feel like I need to grade it. I think you guys are mature enough that I can trust that you're with me. But if I have a lot of people off task and not taking notes, like I'll just start collecting notes every day. Quick check with did you do them or not. If not, you'll have to go back and do them later, which is a pain in the butt. So just please be with me, and then I won't have to do that. Excuse me, I won't have to do it. If you see your classmates are off task or not doing what they need to do, just give them some encouragement, some gentle, polite encouragement. Like, hey, you should be writing that down. Hey, you don't have this. Yes, Scott.
So that I can, some of the dots are kind of close together, so then the numbers will go on where the dots will be. Am I allowed to do the dots in different colors and then write the...
Yeah, that's why I stopped writing the points. So here, I'll show an example of that. So like 4 and 11, that's going to get close in here. Crap, I want green. My board is slightly off. And then my last one, I guess I'll do in black. 3 and 10. So then I can like off to the side here put that that's 3 and 10. Now I can easily see where I can write those things, especially if you're able to change colors. What was that? 4 and 4.25? No, 4 and 11. And then 4.25 and 12. I'm going to take a snapshot of this, then I got to center my board, so don't freak out when it disappears. You guys have probably seen this before, but I know some of you guys, your teachers didn't necessarily have a smart board. Luckily, my board's been okay this year. It actually calibrates better if you give it a moment to figure out where you're at. My board's the oldest smart board in the school, so some of my pixels are actually dead. So what, like if I just tap my marker and one of those pixels right there is bad, it will actually make it like a false point. It has taken me a long time to figure all that stuff out. So like, but now my center should be fixed. And that's also why I do 16 points across as opposed to like, well, it should be 16. It might have actually just defaulted to 9, but I'm not sure. All right, any questions with how we place these points on here or what this shows me?
Mine looks much different than yours.
Do you have the scaling on the bottom being every 4 boxes is 1?
Yeah. Wait, what? Yeah, I did.
Do you have the scaling going vertical that every single box is 1? So, Ava, again, I appreciate your boldness. It's all, like, making mistakes is great. It's all about being able to find where the mistake is. So, Ava, did you just learn something? Wait, okay. Yes, maybe? Was that mistake, like, an opportunity for you to learn? Like, oh, that's what I did.
Well, I did, like, I did what you, like, what you told me. I did every box is 1, but I didn't know that every box, like, you were putting on them. Like, yeah.
So then, just to reiterate, each of these boxes on the x-axis, how much is one of those boxes worth?
4.
Not on the x-axis.
Oh.
If 4 boxes are worth 1, what's an individual box worth? Not 1. 0.25.
Oh.
So guys, you might, especially if you're still struggling with this at all, you might want to label at your first tick mark there, we made that worth 0.25, or the fraction 1/4, because 1/4, 1/2, 3/4, then I get to 1. 1.25, 1.5, 1.75, then I get to 2. Each box there. But guys, this is the weird thing. This is why I'm going kind of slow. The width of a box and the height of a box are not always the same. Right now, one little square is 1 tall and only 0.25 wide. You have to be able to tell your brain, like, this is not a 1-by-1 nice relationship. Now, I know what your brain is thinking right now. life would be easier if every box was one wide and one tall. And I agree. Life would be easier if it was one wide and one tall. But when we had it be one wide and one tall, the graph was hard to read. Right? When we had one wide, one tall, they were way close together. So the reason we modify this scale, spread these points out, make it easier to see.
Didn't we do the same thing on that one to the one that we're working on right now?
Yeah, 108 screwed us up though. It went the wrong way. It changed the graph like in the wrong way. So, Kevin, go ahead.
Why do you have 4 out of, why is it double dot on 3.5 when you, and then you label it 4?
It's 1/4.
No, like the point, the purple one. It's above 3.5, and you label it 4.
Oh, no, yeah, you're right. I think I just probably wrote that wrong. Or I put it in the wrong place. Yeah, I should have labeled that as 3.5. Sorry, there's a 3, a 3.5. I put 2 4s. So my purple point, what Kevin's pointing out, this right here, purple point, I labeled as a 4. It should be a 3.5. Yes, you did. See me after class. In a good way. Everyone makes mistakes. Hey, look, I learned I need to check my graph again, or I need to check my table again before moving on with my graph. Thank you, Kevin. I just learned something. All right, 110.
Now you know.
So, Peyton's got a good graph, right? Now our graph is correct. We should all have that graph, right? A little hard to see with pencil, but down here is where it's labeled 409. By the way, the back is the same as the front. There's nothing different. It was just if you screwed up and you need somewhere else to do this. It's like, Ava, your scale was wrong. Sorry, I should have told you this. The back is identical to the front. So you can try it again on the back. But look at 110. Notice there's no graph on here for 110. 110 is asking us to use the graph that we made in 109. But what it's asking us for is to make a prediction if the bat's body is 2.75 inches long. How can we make a prediction based off the graph that we made? Have you done this in science yet? That if I say the word line of best fit, do you know what I'm talking about?
No.
Wonderful. I get to teach you it before Mr. Kabila does. So here's the thing. When Mr. Kabila goes to teach this to you, you gotta impress him, right? Because I'm then gonna tell him, hey, by the way, my kids know what line of best fit is. They should know when they get to you. Because you're gonna be using this in science as well. So everyone look at your graph and you're gonna need something straight. If you don't have a ruler, grab one real quick, or something straight, the edge of a notebook, the edge of your book, the edge of a piece of paper. Just do it fast. Isaac, that's not gonna work. Come on, man, you know that. Get a ruler that's appropriately sized.
Appropriately sized.
Then grab a seat because I'm moving on because we don't have much time. We have 3 minutes. Yo, no. Appropriate 7th grade behavior does not include smacking rulers on the table. All right, give me your attention up here. When we talk about proportional relationships, one of the things that proportional means is it makes sense, right? So if you had a bat that was 0 inches tall, how big do you think its wingspan would be? 0. So we can interpret or infer there would be a point right down here, right at your 0, 0.
Are you on the top one or the
I'm on the bottom. Sorry, see my cursor moving?
Yeah. Oh.
So then we draw a line. Now, hold up. Don't draw your line yet. We want our line to go through as many points as possible. So if I draw my line like this, it's too high, right? It goes through one of the points, but all the other ones are below. If I draw my line like here, it's too low. So we try to draw the line in the middle of our points. So go ahead with the ruler, connect to your 0, 0 down here, and try to draw a line through as many points as possible and try to just kind of cut through the middle. Now I could tick this up just a tiny bit. I might be slightly low.
This is so bad.
Now, what Peyton is asking for is that bat that's 2.75 inches, right? And that is their body length. So, eyes up on the board again real quick. What we do, I'm going to use some of my fancy smartboard tech to do this. We go for a length on the x-axis. We find 2.75, which is conveniently right here. We then go up until that hits our line. From that point, we go over and find out what is the y value, where that x value hit the line. What is that approximately? 8. Yeah, 8. Right, so our prediction now becomes, based off that graph, we can predict that they would have an 8-inch wingspan, around an 8. It depends on your line.
Good morning, Will Kundu, please come to the office. Will Kundu, please come to the office. Thank you.
That is our prediction. So that's why I put squiggly equals approximately or close to or probably right there. If it's not a graph, then we can do this. What do you mean?
Like, you know, this thing,
Stop, so you're distracting.
you know, like the block tower behind this one. Wait a second.
So Joey's asking, like, how do I use this on like other graphs? Now this kind of comes down to the question of does the x fit? So any value that I see on this graph that I can connect with that line, I can make a prediction. So even if he asks me, predict for a bat that is length 1, I can go from length 1, go up to my line, and sorry, my smartboard's kind of off, and then go over that way, probably about 4 for the wingspan. But if they tell me the bat is 7 inches long, that's off my graph. I can't make a prediction for a bat that's 7 inches long right now. So we might need to talk more later for me to figure out your question, but that is all the time that we have for today, guys. Please save this resource paper. We might use it tomorrow. Slip it in your binder. Don't lose it. Please come to class with homework questions if you have any. Check number 120 in the checkpoint materials. It tells you what to do.